So now what we'll do, we'll find the limit of the sequence. Okay, so determine limit of these two sequences, we'll find that. Okay, so now solution of 1, given that xn is equal to root of 4n square plus n minus twice n. So what we'll do, this is the root now here, we'll rationalize the numerator now. So we'll rationalize the numerator now. 4n square plus 4n, this is minus twice n into root of 4n square plus n plus twice n upon root of 4n square plus n plus twice n. Okay. So we multiply this, what we get then, 4n square plus n minus 4n square upon root of 4n square plus n plus twice n. Okay. Now this 4n square get cancelled. So this will what, n upon root of 4n square plus n plus twice n. Okay. So what we do now? What we do? Numerator there is n now here. The highest degree is n. So what we do? We will divide to each term of the numerator and denominator by n now. So if we divide this to numerator, we will get 1. So this is 1 by root of 4n square plus n plus 2 now. This is plus 2. Okay. Now we will take this 1 upon n inside the root. If you take 1 upon n inside the root, it will be 1 upon n square. What we will do? We will multiply by 1 upon n square to each term of the root now. So this is what? 1 upon. So this is root of 4 plus 1 upon n plus 2. This will be your xn. Okay. Now we take the limit now. So limit n tends to infinity, xn is equal to 1 upon limit n tends to infinity 1 upon root of 4 plus 1 upon n plus 2. Okay. So now this is what then? This is 1 upon root of 4 plus 2. This is 1 upon 2 plus 2. This is 1 upon 4. So your limit is what? 1 upon 4. We'll do the second one. We'll do the second one now. Given that, given that xn is equal to root of n square plus 5n minus n. Okay. Now, what again I will multiply and divide by the conjugate of the numerator. So this is what? Root of n square plus 5n minus n. Root of n square plus 5n plus n now. Right? Conjugate of this is what? If it is a plus b, the conjugate of a plus b is a minus b, and conjugate of a minus b is a plus b. Okay. So now this is what? I do no need here bracket because there is no this single term for this. So this is plus f. Okay. So now what do I have to do? We will multiply the numerator. This is what the conjugate, a minus b, a plus b. A minus b into a plus b is a square minus b square. So this is what? N square plus 5n minus n square upon root of n square plus 5n plus n. Okay. This is your xn now. Now xn. What I do? I will simplify this one. So 5n upon root of n square plus 5n plus n. And what I do? I divide by n to each term of the numerator and denominator. Then your xn will be 1 upon n root of n square plus 5n plus 1 now. This will be what? 1. Okay. I will take 1 upon n inside the root. So it will become 1 upon n square, and then it becomes root of 1 plus 5 upon n plus 1. This is your xn now. I take the limit now. Limit n tends to infinity, xn is equal to limit n tends to infinity 1 upon root of 1 plus 5 upon n plus 1. Okay. So now this will be what then? 1 upon root of 1 plus 0 plus 1. So this is 1 upon 1 plus 1. So this is 1 upon 2. This will be 1 upon 2. Okay. So now we take the next problem. We'll take the next problem. discuss the convergence of the sequence xn is equal to root of n plus 1 minus root n for all n belongs to n. Okay, solution. Given that xn is equal to root of n plus 1 minus root n. Okay. So same for the last one also. For last two examples we have seen like this. So for that what you have to limit. So if the question is asked like that, discuss the convergence of the sequence for the previous one. So whatever that limit is exists, that means what the sequences for the last two sequences are convergent now here. So now what we do, we have to find a limit. We know that a limit is exists and the sequence is convergent. Okay, so what we will do again, we will do the same thing as the previous one. So this is what n plus 1 plus root n upon root of n plus 1 plus root n. Then this will what then n plus 1 minus n upon n plus 1 plus root n now. Okay, so this will be x. So this is 1 upon root of n plus 1 plus root n. Okay, so now if there is no n for the numerator, only n is at the denominator. So your denominator becomes infinity if you take the limit as n tends to infinity. Okay, so this is what limit n tends to infinity. Xn is equal to limit n tends to infinity 1 upon root of n plus 1 plus root n. So this is 0. So therefore sequence xn is convergent and converges to 0. So only the questions are discuss the convergence, just whether the sequence is convergent. It is the convergent, sequence is convergent. If you want to write the convergence to 0, you can write this. So it is enough now, the sequence is convergent, because the question is asked like that, whether the sequence is convergent or divergent. Okay, so that is what here only I have to write the sequence is convergent. Okay, now we will take the next part. So next one is what? Find the limits of the sequences 1 limit n tends to infinity minus 1 raised to n upon n plus 2 and limit n tends to infinity root n minus 1 upon root n plus 1. Okay, solution for first one, xn is equal to minus 1 raised to n upon n plus 2. Okay, so what x of twice n, it is even odd. So this is what 1 upon n plus 2. So therefore limit n tends to infinity x twice n is equal to 0. Okay, for even terms the limit exists and it is 0. So we check for odd term what happen. If odd terms also tends to 0, then your limit exists and it is 0. So x of odd terms, so you have to start from twice n minus 1. So twice n plus 1 is odd, but then n is natural number, so first natural number is 1. If you put n is equal to 1 here, then what, we did not get the first term there. We get here the first term now. Okay, so this is what n. So therefore you have to write twice n minus 1 here. Okay, so now this will what n twice n minus 1, that means your n is odd, and this will be the minus now, minus 1 upon twice n minus 1 plus 2. So this is minus 1 upon twice n plus 1. Okay, so limit n tends to infinity x twice n minus 1 is also 0 now. So therefore limit n tends to infinity xn is equal to 0. Right? So that is what, therefore limit n tends to infinity minus 1 raised to n upon n plus 2 is equal to 0. Okay? You may write this. Okay. Now next one. Second one, xn is equal to root n minus 1 upon root n plus 1. So we'll rationalize this root of n minus 1. No need to rationalize. What we will do? We'll divide by root n to each term now. We'll divide because what here? So we'll divide this 1 minus 1 upon root n. 1 plus 1 upon root n. Now this is very easy now. So now we'll take the limit n tends to infinity. Xn is equal to limit n tends to infinity 1 minus 1 upon root n 1 plus 1 upon root n. So it will what then? 1 minus 0 upon 1 plus 0. So this is 1. Next, discuss the convergence of the sequence x is equal to xn, where xn is equal to n square n plus 1. Solution, given that xn is equal to n square n plus 1. So I can write this is n square minus 1 plus 1 upon n plus 1. Okay. So now this is what then? N plus 1, n minus 1 plus 1 upon n plus 1. So I will separate that. So what we get then? N minus 1 plus 1 upon n plus 1. So I will take this as yn plus zn now. Okay. So where yn is equal to n minus 1 and zn is equal to 1 upon n plus 1. Okay. The sequence yn is divergent. Sequence y is divergent. Okay. Xn is the sum of the two sequence, but we know that the sum of two sequences is convergent. Then the sequences are convergent. Their sum is convergent. Okay. Now here what? The sequence y is divergent. Therefore sequence xn is divergent. Sequence xn is divergent. Okay. Now we'll take the next one. Show that the sequence 2 raised to n is not convergent. Okay. Solution, given that xn is equal to twice n. Okay. We know that twice raised to n is greater than n for all n belong to n. Okay. Sequence n is divergent. Or divergent or it is unbounded. You may say this is what? Unbounded. So that is it is unbounded. Therefore sequence 2 raised to n is unbounded. Therefore sequence 2 raised to n is not convergent. Okay. So it is over now. Okay. Now we'll take the next problem. Give an example of two non-convergent sequences, two divergent sequences. Non-convergent means divergent sequences x and y such that x plus y and x into y are convergent. Okay? Solution. Let x is equal to 1 0 1 0 1 0 dot dot dot. Okay, and y is equal to 0 1 0 1 0 1 dot dot dot. Okay, are two convergent or two divergent, because what r goes to 1 and e1 goes to 0, so these are the two limit point 0 and 1. Here also limit point 2 and 0 and 1 are two divergent sequences. Okay, so what is x plus y? You have to add the corresponding term. So this is 1 1 1 dot dot dot. Okay, and x into y, this is what 0 0 0 0. The constant sequence is always convergent. Constant sequence is always convergent. Are convergent sequences. Okay. So now from this example, what we conclude that? Note 1. If x and y are divergent sequence, this does not imply that x plus y and x into y are divergent sequence. Okay, so x plus y, x and y are divergent. This does not imply that x plus y are divergent and x into y, because we know that the sum of two convergent sequences is convergent. And product of two convergent sequences is convergent. That way. But x and y are divergent. This does not imply that x plus y is divergent, x and into y is divergent. Okay, so that means what? There may be two sequences such that they are divergent, but their sum is convergent. Probably just we have seen that in this example. Okay, we'll do the second note now. If x plus y and xy are divergent, x and y are divergent sequences, then x plus y. Okay, x plus y are convergent sequence. This does not imply that x and y are convergent sequences. Okay, note that x plus y is convergent, right? Sum is convergent. This does not imply that individually x is convergent, y is convergent. Okay, so now see here, this is x plus y now. X is convergent, y is divergent. If both are the divergent, suppose both are the divergent. Okay, now then x plus y will be divergent. One convergent and one divergent. This does not imply that this one. Okay, so note that this what. So sum of two divergent sequences need not be divergent. Sum of two divergent sequences need not be divergent. Okay, so remember these two rules for the competitive exam. Okay, so I hope that you understand all these things. Okay, now we stop here. Thank you.